Hello, 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 hello. Hi,
Hey everyone.
can you hear? Hi, Johan. How are you?
Hi, I'm good. And you, Natya? How are you?
I'm doing awesome. I'm super happy to be here. We're learning live. This is session 3 of Deconstructing Contours of Real Estate, and I'm here from New York. My name is Nithya Narasimhan. I'm a senior cloud advocate on the JavaScript advocacy team at Microsoft, and I'm here with Johan. Johan, do you want to introduce yourself?
Yeah, sure. Hey everyone. So my name is Johanna Sarsa. I'm a cloud advocate in the same team as Nitya. I'm working in the JavaScript team at Microsoft, and I'm also from France.
Woohoo. And I think we have a couple of our friends on board right now as well. So say hi to our moderators. Want to give a shout out to the amazing Dina Berry and Glaucia Lemos. Dina is a content developer at Microsoft who knows a lot more about JavaScript on Azure than she should. And Glaucia is based in Latam and is one of the members of our JavaScript advocacy team. And Johan, were you there for the first episode that we did with Natalia? Do you remember what we were kind of talking about? Should I go through some of that?
Yeah, actually, I missed the first one, but I know the second one.
All right, so I did the first one, so let me tell you about it. This is about deconstructing contours of real estate. We are going to walk you through in 4 episodes how to look at an open source enterprise grade sample and figure out how to take lessons from it that you can convert into knowledge for building your own apps. In episode 1, we learned what a composable architecture was. We learned how to do configuration as code using dev containers and code spaces. And we set up our development environment to build and preview the app. So if you want to participate today, don't forget to get started on that already. And then I think you did episode 2. So Johan.
Yeah, I've seen that one. So basically, Natalia and Glosia went through discussing how and why the application was constructed, building from an API first design, how the blog application was implemented. They've also shown how the portal application was implemented and worked basically through all of that. There's also special parts about TypeSpec, which is a very nice tool to use.
Yeah, and of course, we are now here today in episode 3. We don't have to tell you what we're working on because you're going to hear it all, but we're going to talk about authentication, we're going to talk about payments. It's also the last in the development episodes in the series because the next one will focus on deployment. So if we have time, we're going to wrap up a few loose ends as well. And I'll talk about the fourth one simply because it's one of my favorite things. In the last one, please do register. The QR code is on there. Register and show up for that one because there we're going to talk about a really awesome tool called Azure Developer CLI that will help you do deployment to Azure with a single command tool. And we'll also talk about my favorite tool, which is Playwright, and how you can do end-to-end testing of such enterprise-grade applications. And Johan, have you heard about Fall for Intelligent Apps?
No, can you tell me more about it?
Oh, that was too good. So all of this is part of a really awesome initiative called Fall for Intelligent Apps. It's from cloud advocacy, from the product marketing teams, and from the product groups. And what we're doing is we're trying to get you to learn about how you can use cloud scale data with cloud native technology and cloud integrated AI to build a differentiated experience for your enterprise customers. Check it out. And all the Learn Live series that we talked about will be listed on that page. So just go to aka.ms/fall4ia. And I think we need to give you a little reminder of what we're doing. So Johan, what is this that we should talk about?
Just be aware that everything that we will be presenting today is from a code base that is moving constantly. I mean, literally, I made changes to the code just yesterday. So it's okay if you see documentation missing, if you see things breaking. That happens sometimes. Even though we avoid doing that. And it's also okay because the samples and everything we'll be presenting today is open source. So feel free to create issues, start discussion on GitHub, file bugs. Basically, we love that and we live for that. So
yeah, and the reason we're telling you how to go and look at the open source is we're hoping you'll come help us fix some of these. So open source, and October is a great month to do open source contributions. So definitely do come help us. And then just another reminder, this is Learn Live. That means that we want your participation. We love hearing from you. And Glaucia and Dina are really awesome people. So say hi on the chat. I'm from New York. Johan is from France. Where are you all from? Let us know. We'd love to hear from you. And if you've come to previous sessions on this, if you have ideas for things you'd like to have us cover now or in future, put those in the chat as well, and we'd love to hear it.
Yeah, this is a good reminder that this is not a recorded show. We're live. We can do fun stuff like this.
Yes, and it could crash.
And yeah, we're not AI. We're real person. We're real people. We're looking at the comments. So yeah, you can just tell us what you think. Ask question in the chat.
Yes, and now we're getting started. We are learning live. So let's get started. And this is a 4-part series. So I'm going to tell you what the bigger picture for the 4-part series and then hand off to Johan to tell you what we'll cover today. So the 4-part series, we really had 2 big broad objectives, right? One was architecture and one is development. From an architecture perspective, we wanted to make you understand how to build an enterprise grade app using a composable architecture with multiple extensible scenarios so that you can continue to evolve it to suit whatever your new requirements are. And it is an open source reference sample. The other hand, we really wanted to tell you about a best-in-class developer tooling from code spaces to Azure Developer CLI, from Playwright to SWA CLI, and things you can do to make your life as a developer easier. Plus Copilot, my favorite. I forgot. Do you want to talk about our learning objectives for today, Johan?
Sure. So for today, we will walk through different things. The first thing is authentication. That's a very important part in the application because with authentication, we cannot have like user information. We cannot do everything else that relies on that part. So Nitya will take the lead and show you a bit on how authentication works in the application. Then we'll walk you through how the whole reservation flow is implemented inside the application and how we implemented payments integrating a third-party service, Stripe. And at the end, we'll show you a glimpse of what's coming next also in the application.
And so the prerequisites, the great news is all you need is actually a browser to participate today. That's all you need. But in reality, there's going to be Visual Studio Code. Familiarity with it is great. You do need a GitHub account so you can check out a fork repo and kind of start playing with it. GitHub code spaces, there's a free usage quota. There are a lot of tips to make sure you'll never exceed it. It's a great tool, so you definitely want to make sure you've activated that. And optional GitHub Copilot. If you go through this whole series and go to the episode 4, you might want to have an Azure account ready to try deployment. But for now, that's not needed. And then I think, should I get started on the first? Oh, let's actually give them a heads up on what they should be doing. Do you want to talk about what they should have done before they came here, Johan?
Yeah, sure. So first, if you want to follow along, that's not mandatory, but it's best if you want to practice and put your hands like in the code for real. You should go to this GitHub URL. I think it's already shared in the chat. And then fork the repo. That's the first thing. So basically, it will make a copy of your own repo, and then you can make all the changes you want in that space. And if you want also to follow along for this session, I will be using Codespaces. I think Nitya also will be using Codespaces. So you can start Codespaces if you want to go. There's a free tier. And for the first time you launch it, it may take a few minutes to set up. So you can just go start it now. So you're free to follow along after that.
Yeah, and I snuck this in here because this is now my favorite tool. One of the things that I was telling Johan as we were kind of waiting backstage is that this is a project that was done by members of my team, and I'm literally playing the part of someone who's coming in and trying to figure out what was built and how I could actually understand it through open source. And one of the tools that has been super important to me is Copilot. It is optional, you don't have to install it, but I'm going to try to see if we can show you at least one example of how that can help. And if that looks like something you might want to try, I think there is a 30-day free trial. And it's now, if you have a Copilot subscription, Copilot Chat comes with it as well. So we'll see where that goes. But yeah, should I jump into my section, Johan? Are we ready?
Yeah, sure.
All right, so the first part, we've broken this into 2 parts. I'm going to do authentication, Johan will do payments. So in this, we're going to talk about what is authentication, why is it a core scenario, and how did we implement it in this app. But you may all not have been there for the previous session. So we're going to do a really short recap. What is Contoso Real Estate? The repo that we just forked, it actually has user stories. So bigger picture is Contoso Real Estate. The story is it's an organization, Contoso, that has this real estate app that is being used to onboard or kind of allow people coming on to the company, onboarding new hires to find temporary housing. So what we have is 3 kinds of users. First, we have the administrators, right? Like the HR folks who are going to say, hey, we want to have a blog. We're going to put the blog content in. We want to have featured listings that we approve of. So we want to tell you what those are. So the admin users are actually filling in the listings for a portal app and they're filling in articles for the blog app. Then we have guest users. These are people who are just kind of browsing these two apps. They have no credentials, nothing, but they can see whatever's publicly visible, which means they can see the featured rentals and they can read the blogs. And today we are actually saying, what if? What else do they need? An authenticated user in a portal may want to save a listing that they really like. They may want to reserve it with a payment. They may then want to kind of look back and see what the history of all their activities are. So those are the features we want to actually implement. If you've been here in our previous scenario, in our previous sessions, you might have seen this architecture slide. At a very high level, you will see it's an extensible scenario architecture. That means we're stacking scenarios one at a time on top of each other. How do those user stories map to this journey? First scenario we heard about was building the blog. And what it did is it really focused on the admin. We had a CMS, we had the blog app, and the admin is able to go in and populate all the content. Second scenario was we added the portal. At this point, now those listings data that the admin populated are now visible in this app that you can go and see. And then we started kind of looking at, hey, what's next? Today, we're going to cover scenarios 3 and 4. I will do auth, and Johan will do payment. So, Johan, do you remember this thing that I told you? This is like our scenario. So let's assume one of those people there is Johan, right? And I am this person who's come into this team. So the scenario that I want you all to think about is to be just like me. You've come into this team. You've got an open source repo. Your boss says, I have a challenge for you. We already built this app with the guest experience and the admin. Now we need to kind of do listings and we need to do payments. The team has already started working on this. Go familiarize ourselves and understand how this works so that when there's more work down the pipe, you can get it done. Right, Johan?
Yes, definitely.
So I'm going to go ahead and say, I remember this. So for what it's worth, Johan and all the members of the JavaScript team have been involved in static web apps. SWA stands for static web apps for the longest time. So we knew that there were a lot of resources we could learn from. The number one resource that I want to point to is, of course, the reference sample itself. Fork it, open code space, and we'll start working through it. The second one is this Azure Static Web Apps Learn Path. There is a link in the chat and there's one on the screen. Why is it important? Because it turns out what I'm going to talk to you about is actually covered in that module. You can make connections once I'm done. And the idea is that by understanding it, you can then transfer your knowledge here. Do you remember doing this path? Johan, was it easy?
Yeah, fun fact, I actually wrote literally the module you're showing on screen.
Okay, so if anything goes, if you have any questions at all, you have the person who wrote the module. So there we go. And this is actually still one of the most popular modules, so yay. So what do we want to talk about? Now, let's settle down and start thinking through this authentication use case, right? We know that the portal app uses Azure Static Web Apps. You learned that the last time. What is Azure Static Web Apps? For a quick recap, it's really about taking your static web app and breaking it into two things. All the static assets, which you can distribute in a content distribution system so that you can get them from anywhere in the world as fast as you can, because they're just static assets. And then the interactive processing implemented as serverless functions. Now you only pay for what you use, and you can scale up and down as demand grows. In addition, static web apps gives you something really nice, which I absolutely love. It has a managed API, so your serverless functions and your app really work very closely together, and you can wrap them and deploy them together. It has managed authentication. Why would we not use that? So we're going to talk about that. It also has first-class CI/CD support. So the code-to-cloud experience is so simple. You write your code, you commit it, and it's automatically built and deployed for you to the endpoint in Azure. Most importantly, it just works with most of your popular frameworks. If you're writing a Svelte app, if you're writing a React app, if you're writing a Next app, if you're writing an Angular app, it just works. So I also want to give you one last resource. If you are not familiar with Azure Static Web Apps, our entire team actually got together last year and wrote the series called 30 Days of SWA. SWA stands for Static Web Apps. So if you're looking to kind of understand everything from concepts to implementation and tooling and best practices, we have 4 weeks worth of content that I absolutely promote. And I'm actually going to use the securing SWA, which is the auth part, that we will cover today. So today we're going to talk about Azure Static Web Apps, and we're going to look at these objectives. We want to add authentication to this Azure Static Web App that we've already implemented. And then we want to use that authentication information to do something. What do we want to do? We want to use it to control access to routes so that an unauthenticated user does not go and see things they should not. We want to use it to give a profile page and allow someone who's authenticated to go in and see data that they've actually done on the site. And then maybe we'll use that to influence the user experience. Here are the 5 concepts that I hope to cover. I don't know how much I will because time flies, but we'll see. First, what is managed authentication? Next, we'll talk about standardized path, how easy it is in static web apps because they give you the 3 features you really want, which is login, logout, and user profile information. Third, we're going to talk about built-in roles. You don't even have to think through what your roles are. There is a guest role, anonymous, and an authenticated role, which is the default when you log in. And beyond that, you can write more custom roles if you want role-based authentication later or authorization later. Last but not least, they make user information access so easy, both from your app and from your API. And again, shout out to Johan. Johan, do you know anything about the SOA CLI at all?
I remember doing quite something with Wasim on this particular tool.
Yes, so if you actually go see this, we have a static web app CLI, an open source tool, which is the one tool that rules it all when it comes to static web apps. And the beautiful thing about it is you can test authentication locally because it has an emulator that gives you fake user identities and lets you actually try out your flows without actually going into the world and using, like wrecking someone's account. So before I go through this, let's go through the scenario so you all understand what exactly this looks like. So I'm going to walk through this really quickly. The idea is this is Contoso. This is our portal app. And as you can see, when you start off, this was halfway through. Let me start it from the beginning. A user comes in and they come into the screen. They're a guest. They can go scrolling through the listings. And then they're like, there's a login button. Why would I need that? They're like, let me go browse listings. I don't need that. I can see all the listings for free. And then they go view a listing and they realize, okay, I actually want to reserve this. What do? I need to log in before I can book it. Now, how do I log in? Look how easy it is. It gives me a bunch of custom providers that are well known, gives me a section where I can put in my details, and I'm logged in, done, right? This entire flow is managed by static web apps. Now, you can also see 2 things. You start seeing a little bookmark icon. Now I can actually bookmark and save this. I can also go through this whole payment process and reserve it. And I'm not going to show that to you because Johan's going to do the demo later. But once I'm done, I get to a profile page where I can see the history of everything I did. I can see my payment history. I can see the reservations that I made. And then I can go in and favorite it because this favorite icon showed up once I was logged in. Now I can go favorite it. And if I go into my favorites, ta-da, it's over there. And I can remove it. Done, right? So this is the experience we want to enable. I'm going to stop this right now so we can go back and actually talk about what just happened. What happened under the covers that made this possible? So first, I told you we'd talk about managed authentication. The experience you saw is managed authentication in Azure Static Web Apps. What does that mean? First, it means we have pre-configured providers. Out of the box, Static Web Apps is going to support a number of popular authentication providers like Twitter and GitHub and Azure AD. They do have a caveat on there right now because we all know it's x.com, so your mileage may vary with Twitter, but it's as easy as figuring out what your provider is. We'll also talk briefly about pre-assigned roles, customized roles, routes, and user info access. But first, let's talk about what that looks like in code. How do I get this UI that you saw that shows me all the custom providers where I just click it and then it finishes the flow for me? If you've got, at this time, if you've actually launched your code spaces and it's running, you should be able to see a screen, something like this, which shows you the code. On each of these screens, you'll actually see, you'll see the file name. I want you to go to source, app, authentication, and authentication component. I have it right here, so we're going to go look at it. There's source authentication component. And you will see that this is the component you just saw rendered on the screen. And all it's saying is here, there's a bunch of providers. Let's render them one a piece, right? Or one button a piece. What are those providers? Here they are. So when you're going to go look into the code, let's say you want to modify this code and you don't want all these providers, you can just select and remove whatever you want. And if you go look at the documentation, you can also write custom providers. You can actually customize the behaviors of these providers if you so choose. And what you'll notice is that in addition to this, there's also something called redirect with default. And let's just briefly look at what that means, right? So it turns out that when you have a provider and you log in, we're going to talk about this interesting URL here. But just know that at this point, when I log in, I'm remembering where I was when I clicked the login button. And the redirect allows me to pass that information to the login flow so that when the login flow is complete and I come out, it says you are there when you finished. You want to go back to where you are, but except now you're logged in. And that allows the user to have a continuity of user experience in the application. So that's one place that you can see where we've already got a win. We didn't have to do anything, right? Next, let's talk about those standard paths. So we talked about I think I mentioned this, that out of the box, static web apps will give you two roles. When you log in, you're authenticated. When you don't, you're anonymous. Just remember those two words. But how do you actually, can you actually see how this login process happens? It turns out that static web apps provide standard routes. It's as easy as that. So there is a /auth/login. You can go to that URL, add the name of a provider, and it will initiate the flow with that provider. You don't believe me? You want to check it out? Let's try this. So right now, I actually have this running in code spaces, and I'd already run this. Hopefully none of this has glitches right now, because sometimes my code spaces goes idle and then it does not like it. But for now, here's the portal app running in code spaces. This is the development environment. If they're right, then I should be able to go to .auth over here and then just say, hey, I want to log in. Oh, my typing skills are terrible. I want to log in, and yeah, why not? Let's use GitHub. Ta-da! So although we are binding this into the buttons and different places in the app where we want this login flow to start, I can just as well do it from the URL route. It is that easy. Now, this image, we'll talk about it later, you'll see is actually a kind of like the emulated version, because it's giving me a provider and it's actually faking my ID right now. But let's roll with it. We'll talk about this later, but one of the things you'll realize is as part of this, I can actually ask for the roles that I want this login flow to have. And when I go ahead and log in, it has now logged me in. And if you remember the things I said here, there is a login, there is a log out, and then there's auth.me. Let's just, for the heck of it, see what happens, right? Okay, I'm logged in. What does auth.me do? Any clues? It gives me the user login information, the client principal. So effectively, anytime I want to get data about who's logged in, I go to a route. And now you know where I'm going with this. If I want to log out, and we can actually make sure that I'm logged in before we do that. So if I go back to this, you'll see I should be logged in still. If I go in here and just say auth.logout, now why am I telling you this? I'm telling you this because you have to realize how ridiculously easy it is to work with static web apps, right? I'm logged out. In other words, when I'm actually writing my app and I want to bind to these routes, if I bind to the route and actually have the user go through it, that's all I need to do. I didn't have to write anything else beyond that. So we've looked at these paths, and here on this side, you'll see that I have this authentication component.ts. Now you can make the connection between how I pick a provider, and then when I have a login command, I'm actually fulfilling it by just calling that route, giving it the redirect URL and saying, please fulfill this for me. Next, for the logout, we saw the same example, but I'm telling you where you can see it being used in the code. We did it through the browser in the actual application. But if you go into the main nav, and the main nav over here is really this, here when I log in, I'll get a logout button. I can go into the main nav. I think it's somewhere, where was it? I need to remember where this is. It's under shared and main nav. Okay, so under shared, there is a main nav. Okay, here it is. And so you can see that over here, I actually can just bind that button to a logout flow and I'm done, right? But in both of these cases, we have this thing where, yes, I can now log in, log out, so super easy. And when I'm logged in, I know where I can get the data. But I still need to be able to use that data in a useful way. How do I use it? This is where the most beautiful thing in static web apps is how I can use the user's identity and role to actually control access to routes, right? So this is where I want you to remember staticwebapp.config.json. We're going to go look at that file in a minute. But what you really want to think about here is, what is it doing? I've put the code in here, but let's go look at it here so I can open it up really big. In general, that file will be at the top level of your application. In an Angular app like this one, they actually put it under assets. So you'll find it here under assets and staticwebapp.config.json. So feel free to go look at it there. And what you can see in here is that it's defining all the routes in your system. And right now it's looking at the API routes. And we're going to talk about the app routes later in a nice twist. But For now, I'm just saying, hey, the APIs have routes too. You want to be convinced that there is an API route? Sure, let's go look at it. There is an API listings route. Ta-da, there is data there, right? So I want to be able to make sure that I want certain routes to be accessible to guest users, but I don't want some to be accessible unless you're logged in. What are those? Those could be things like reservations. I don't want other people to see what I'm booking. I don't want other people to see what I'm liking. I don't want other people to see my payment information. So those can be locked in by saying your allowed role is authenticated. And that means that I, just by writing this, have told static web apps, please, unless the user's logged in, don't let them go there. And static web apps knows about the authentication state because it's maintaining that for you as well. Simple, right? So remember that static web app config.json is where you will go to actually associate roles with your routes so you can lock down access to routes. There's also an interesting thing that you might have seen in there, which is this navigation fallback. What is that? Hey, the minute I start locking down routes, that means that when a user goes to a route they're not allowed to go to, what should happen? I can throw a 404 and put an ugly page, but I might even be able to use that as a way to direct them somewhere else into my site. And that's what this is. So over here, you're seeing that if I go to a route that I'm not supposed to access, it'll just redirect me to the home page. All right, I think we're doing good on time. Someone keep me honest. We already saw how to access user information, but how do I use it? So once I have that information, I can use it in something called, like in this code, what it's being used for is to, in two different places, it takes that user state and stores it locally so that I can now access it without having to hit a call every time. And then using that, it creates an authentication service that gives endpoints that says, okay, is the user authenticated? What role do they have? But then here is a nice use case for how that gets used in our app. So if you go into this, go into shared has role has directive under a portal source. So we're looking at portal source, and then I think app. So what is shared? And then something like this, right? So if you look at this, it's basically saying, I'm going to set up a directive where I'm going to tell you, based on the role, whether you should show something or not, right? And now we can use this to bind to elements in a way that I only show certain elements when I'm in a particular role, which could be anonymous or authenticated. How does that work? This is why when you're not authenticated, you can go to a profile page. If you go to a profile page, it should actually redirect you to home, right? Because I don't have access to it. Oh, it goes into 404. But if I log in at this point, then I should be able to go into that and see a profile page. What? Wrong route. Oh, sorry. Yes, it's not profile. It's me. That's why. Profile doesn't exist. But now I can see this, right? And now what I'm really looking at is how can I use this to influence other parts of my UI? And this is the exact same reason why when I look at this with my login, I should be able to see a bookmark on the main page for some of these listings, the bookmark icon. And when I log out, I don't. And I think I've put a bunch of examples here that you can go look at. But in the interest of time, I'm going to move ahead. So favorites visibility is one thing. The profile page is another. Each one of these has links to the code where you can go and check out how that has role is being used to influence that. But now I want to go to something interesting, because I do want to show you how, even if Johan or me or Glaucia or Wasim, even if we're not there, how can you do something useful to explain this for yourself? So you might remember that I said, hey, we can actually lock down routes, right? But the routes that were in the static config.json were only the /API routes. But I know that there are other routes in here like /listings, right? So if I actually go into a listings page, I know that if I go into view listings, I know that there is a page. There is another route. Where are those coming from? It turns out that when you're working with Angular, there's an Angular router as well. So I need to remember where this is. So I have to put the caveat that I'm not an Angular user. And this is why I hope this is useful for you as well. I'm coming into this open source thing saying, I'm not an Angular expert. What does this routing code do? I really want to understand what it's trying to do over here. So let's go look at source app routing. So source app, and you can see that at the bottom, there is this routing file, right? I'm like, I just want to understand what it's doing here. I know that over here, the profile says there is, I can see the profile has these tab panes. What is this doing, right? This is where if you have GitHub Copilot, this is a great time for you to just go to it and say, you can do one of two things. You can select it here, like so, and say, all right, I want to understand what this code does, right? And I can basically do I think it's a command I, and I say, hey, can you please explain what these routes do, right? And you can see that it's thinking here. Oh, it doesn't say routes. All right. I would say, I'm going to do this over here. Am I in this? I'm just going to say, explain to me what the code does, because I don't want it to say routes. Explain what this code does. And now here it does actually understand now that this is part of a routing application. It tells you what the matcher does. It says, hey, it's looking at this route, and it's looking at what the extension of the route is. And based on that, it's going to set the active tab, et cetera, right? To me, this is really, really powerful because it lets us kind of intuitively figure this out. But now look, under this, it then gives me this follow-up saying, how can I use this in my Angular application? So if you're exploring this code by yourself, do think of like using something like Copilot to educate yourself, explore it, and ask open-ended questions. And now I'm going to actually hand off the reservation flow part to Johan so you can see how this works over there. But before we kind of wrap this up, two more things. You saw that in the auth flow, we actually used a fake ID. We were using a local development workflow with the SWA CLI. What does this actually do? So this is the static web app CLI. What it is it's kind of like a proxy to three different things, right? You already know that the static web app is giving you three different components. It's giving you the app, the hosted assets. It's giving you the API, which is an Azure Functions implementation, and it's giving you auth. And so if I want to actually test this out, I can use the SWA CLI emulator, and it does a bunch of things for me. It gives me a fake user ID and allows me to set things like the URL, the roles for the user. So I can test my behaviors against a local emulated user or configurations of that user to make sure my stuff works without hitting real user accounts, which is super cool. So if you see this, for example, that's what it is. That provided GitHub, when you actually use it in production, will go to GitHub and complete the flow. But for now, you can get back a principal. You can get the data from that authentication flow, and you can use it in your app to test it out. So now I'm going to give you one exercise to wrap the section, and then we'll kind of move on to reservations. We've talked so much about this, so fingers crossed, let's try a demo. The main thing that you need to understand is when I'm logged in, my login state lets me influence the access to routes, right? So if you understood what we talked about, then you should be able to do something interesting. Right now, I am not logged in to this app. And when I'm not logged into this app as a guest, it looks like I can actually go to the listings data and see it. Horror. And I can actually go to the home page and see that listings data being used to implement these cards. What if I didn't want that anymore? What if I said, hey, I actually want to have this stuff, the listing should only be accessible to authenticated users. Right? I should be able to do that. I'm just going to kill this, and this is usually typically fast. So let's start this up. Once the ports are all back on, we can go check it out. So all I've done is I've said, hey, I'm going to go into this config file, and I'm going to change it so that the route to listings now requires me to be authenticated. And I'm waiting for the portal to turn green. The minute it does, we will go, okay, let's go see. Did that work? So now let me try if these demo gods work for me. Ta-da! The listings are not showing up anymore. Let's see what happens. If I try to go to the API, it says you're no longer authorized. As simple as that, based on the role, I am able to now change how users access the different parts of my application. Note that not only did we impact the API, but impacted the route that used that API, right? It was waiting for the data. So with that in mind, I think I'm done with the section. We're going to just do a knowledge check. Hopefully I'm on time to hand it off to Johan. So first time knowledge check. We talked about how static web apps makes it super easy for you to log in. What route pattern would you use to make an authentication request? Johan, I'm not going to ask you because this would be cheating. You know the stuff too well. But any clues?
I have my ideas.
I don't know how long are we supposed to wait before. Should we just try? Okay, we're gonna. I don't know how we know whether everyone's done, but if everyone's on the chat, go try guessing it all. Just put it in the chat, whatever. So we're gonna see what the answer is. And did you guess that, Johan? Did you? I think so. I really like this because what it's basically saying is that it's easy as saying whatever provider you're putting in there, that will be the one. Put it in the URL, and you've got your auth flow going, right? All right. The next one is a little more tricky. We actually did an exercise right now, and we've talked about it many times. So where should I configure route access control based on this authentication information? There are a ton of config files in this project. Which one should it be? Is it A, your VS Code launch.json? Is it the function.json that's in the functions implementations? Is it the static web app.config.json file that's under the app folder? Or is it the package.json that's at the root of your GitHub repo? Which one of these is it?
We have definitely too many config files in our repo.
I know. That was my thing. And we haven't finished. I think there's some more, if I'm not mistaken. We haven't put them all in there. If we really dig, like dev container.json, there's one more. Oh, yeah. So do you want to guess, Johan? I'm not sure how polls work, so we can just move ahead, I think.
Yeah, I think we can wait a few more seconds for people to join the poll.
Awesome. I don't know how to look at these polls, but
yeah, I think the poll is going live, but there's a bit of a delay between what you're showing and the time people see it.
Gotcha. Also, in the meantime, I don't know if there were any questions, but if there were, we can take them. Bottom line is, like, hopefully at this point, you're getting this idea of we're using managed authentication in static web apps. We're using some of the things that are also already built in to the product. And it's actually super easy. So I think we should put Jeopardy music next time.
It would be fun to have that music in the background.
That should be the next hack project for Laurent. We put Jeopardy music.
Nice. You just have to ask.
You just have to ask. Laurent is awesome. For all of you out there, Laurent's a producer. He asked for Jeopardy music and he's actually playing Jeopardy. Well, he's playing some music, so this is great.
Okay, maybe we should move on to the answer.
Yeah, awesome. So the answer is the static web app.config.json file. I hope you all got that right. And so at this point, that was your speed introduction to authentication, managed auth in static web apps, what providers you can use, where you can find your config files to do access control, how you can use routes to actually automate the flows, and how or where you can find the code in our open source repo that shows you how to map it to the implementation. And now I want to hand off to Johan, because this is something I really wanted to learn about. Johan, are you going to share your slides for this segment?
Yeah, so now let's switch to my screen and we'll talk a bit about payments.
Woo-hoo.
So is my screen live now?
Yes, I think it is.
Okay, I see my mouse, so it means that I'm live. So yeah, first we'll start by answering this simple question. Why is payments a core scenario? And I think as long as you're looking to build an e-commerce website, that's quite an easy question, because you want to be able to accept payments for your customers. Otherwise, you're not doing e-commerce. So what we'll be looking at in this section is how did we implement payments in our content store real estate application. So this is what we refer as the scenario 4, looking at the same schema a bit cropped in there as Nitya shown in the beginning. So basically the idea here is to add support for payments, so customers are able to complete the reservation workflow inside the application. And because this particular scenario is kind of like the complete form of the content store real estate application, it's built upon all the previous scenarios. That means we need the authentication that Nitya just shown you before. We need all the other stuff that was built in the previous session. And it built upon these components and to add a few more so we can have like the complete thing. So we're using a few Azure services. Nitya already spoke about static web app. We're also using function to have the API. All the listings are stored in a PostgreSQL database. That's what was in the previous episode. But now we need a place to be able to store all the reservation, all the
Yeah.
user data, the payments, all the stuff. Basically, once you have your own accounts, you need a place to store that. And for that, we'll be using Azure Cosmos DB for that. And we'll be using that particular database with a MongoDB API. So that means it will just act from a developer point of view, just as a regular Mongo database, just to store our stuff. So we've seen that the portal application was built with Angular. We've seen that our API for the front end was built with Azure Function. And now we need to add a new service to handle all the Stripe stuff. And we will package that service inside a container and deploy it on container apps. And this particular service will be built with Fastify.
Oh, I was kind of waiting for you to say that. I'm like, what is Fastify? I really want to know.
So yeah, Fastify is a Node.js framework. If you use the Express, maybe it's a bit similar, but there are a few advantages of using Fastify. And one of the first reasons we moved to Fastify is because it has out of the box full support for TypeScript. So it means TypeScript support is integrated, and it has also some other nice things that you will see in the code just after that. And the final piece to make everything works for the payment is to have a payment provider. And that's where we will be using Stripe. So it's a third-party service that we will integrate in our application.
Wow, so this is cool. I think this is one of the only scenarios where I've seen two different computes being used so efficiently. Like you've got both functions and containers.
Yeah, definitely. So moving on to the trick question. What's Stripe? If you never heard about that, you've probably already used that without even knowing that's Stripe behind that. So I just said that before, it's a payment service provider. So what does it do? It makes you allow to accept payments worldwide in most of the countries. It supports a lot of different currencies. So that means you can have an application and deploy it in different countries. And it will handle all the heavy stuff for you, handling the billing, all the tax and invoice stuff. That's usually a bit complicated because it's different from country to country. And it's quite easy to integrate within your application because it provides an SDK that works with a lot of different language. For our Content application, we'll use the TypeScript version of the SDK, but it also works with Python, Java, .NET, Go, and some other languages. So what I want to do now is switch to a real deployed version of the application. So this one is a version of the application I already deployed on Azure. So previously, Nitya have shown you the application working locally in Codespaces. This one has been deployed. So that's also why it's taking some time because it's deployed on Azure Function and because we want it to be a sample that doesn't cost you a lot to deploy. We choose like a free tier for the function. That means it goes down every time nobody is using that. So there's a bit of a warm-up time. So once you have the application, you've seen that before. If I want to book a particular listing, I need to be logged in. So let's just log in. So this time I'm against the real static web app authentication. So that means you don't see like the emulator screen Nitya has shown you before. This is the real thing. So I'm logged in with my account. And now I want to book a particular one. Let's take like this one. And let's pick a period, like in the future, like in December, that's a good time. I can choose any number of guests. And now we'll start the real thing, like the payment flow. So once I click on this particular button, you can notice something is that we switch websites. So now I'm inside the Stripe website. We've been moved out of our website. So as you can see, there's a test mode in there. So that means that I've configured Stripe in development mode. So I can use fake data, especially fake credit cards, because I don't want to be billed for that one. And then I can enter like information. Okay. That doesn't matter if it's good. And if you go to the Stripe documentation, you can see that there's a lot of different fake card that you can impute. So that particular one will make the payment succeed. So as again, I will say that it only works because Stripe is in development mode. It won't work with real instance of Stripe. Just so you don't try to use this card on other apps. So now, if I click on pay, it should succeed, hopefully.
That's actually a very cheap apartment for a number of days. $200 is very cheap.
And then we redirect it back to our application. And you can see that, okay, the booking has been successfully made. I can go and see it in my reservation. So I did a few before in the past. I can see also that the payment was made with Stripe. Basically, we've seen everything as it would appear for a customer on your deployed version.
And I really like that it also has the tag that tells you there are payments that are pending versus active. That status is super cool.
Yeah, we'll talk a bit about that later. Pending basically means that I wanted to book a particular listing, but I did not went along with the payment. So that's a particular state. We'll talk about that. So what did just happen in terms of data flow between our different services? So I've explained that in the beginning. We have a few services needed to make that happen. We have a few components in there. So we'll see what is basically the role of each component. So we start with the portal. Basically, what happens when I start clicking on that Reserve Now button. So what will happen is that the portal will make an API call to our API service. It will call the checkout API. The first thing the API will do is create a reservation in the database. That's it will give it the pending status we were talking just about. We need to do that first because you don't want to have like multiple clients trying to book the same apartment at the same time, and one ending up paying and not having the reservation because it wasn't like blocked for him. So what we do first is we create the reservation and we lock that particular reservation so others cannot do the same. So first one has the reservation. Then the API service will call our Stripe service internally to initiate a checkout session. The Stripe service, so the one we have in our that is part of our application and deployed in Container Apps, will then use the Stripe SDK and call the Stripe API, so outside of our application, and ask to create the checkout session. It will gives the few parameters like where the application should redirect in case of success, in case of failure, how much should the user pay, and stuff like that. Mm-hmm. And the Stripe API will basically create stuff on the Stripe side and gives back a session URL. And this particular session URL will be bubbled up to the portal. And that's this particular URL we've seen a few times ago in the browser, because that's the one we use to redirect the user to a different website. Once we get the session URL, we basically redirect the website to the Stripe checkout website, so the customer can, like just as I did before, enter the credit card information. Once it's finished, the Stripe website will redirect to our portal website. And that's what we have seen when everything goes right, we've succeeded. But there's still one question. Do we have one question, Nitya, seeing that? There's still something missing in there.
What is missing in there?
How basically our service are notified when the payment occurs.
That's good. Yes. So, it's very important I know if my payment or if it double paid or whatever. Yes.
So yeah, to get notified of any Stripe occurring on the event side, because this particular part where the customer pays doesn't happen on our service. It happens all on the Stripe website, and we have no knowledge of what's going on in there. So basically, we have set up a special API called the webhook on our Stripe service that the Stripe API will call to notify us from events occurring. In that particular case, if a payment succeeds, like I just did, paying on the Stripe website, an event will be sent to this particular Stripe service. And then once the Stripe service will check that this event is legit, that's a valid payment, it will call internally our API service to create the payment and then update the reservation status to say, hey, it has been paid, it should be active, and everything is good for now. So here we have like the complete flow of what happens when you're trying to pay within the application, and what happens also and how Stripe integrates within our application.
Oh, Johan, I think someone may have missed what you said was missing in that flow on the chat. So they were asking what was the part that was missing. I think that was the webhook where you were talking about the last bit of the flow.
Yeah, the part that was missing was the last one I explained is the webhook thing. Basically, it's something that's it's not really obvious on that particular schema because it happens basically at the same time as you finish validating your payment on the Stripe websites. And in the meantime, you're redirected in the portal. You don't see it, but the backend receive an event from the Stripe servers. We receive it through our webhook API. We process that to validate the payments and update the reservation on our database. So that was the thing that happens in the background that's directly triggered by Stripe as an event. We have 3 components, not counting the Stripe one because it's a third-party service. We have 3 components on our side, and we split our API and our application into these different components, as it was explained in the different sessions that were happening before, because we want these components to have very scoped responsibilities. The portal, it's easy. It's the user interface. It's where you want to see and create new reservations, see the existing ones, see the payments. The API service is the part that its responsibility is to communicate with the portal. It will also handle all the user information, basically create, update, list reservation, create or list the payments, also handle, this is not something I'm showing, but it will also handle like the favorites, something Nitya has just shown before. And the Stripe service, its single responsibility is to communicate with the Stripe servers. Basically, initiate the checkout session, so we get the URL to redirect the user, and handle the Stripe events that are coming through the webhook. So I've been talking a lot, but everything we implemented started from these particular functional requirements. So the first thing, as you explained in the beginning, basically you can't do anything as long as you don't have your user authenticated. So first we need to authenticate the user so we can have like their own private data. And then once the user starts clicking on the Reserve Now button, we need to ensure the validity of the reservation request. We need to check a few things in there, like is there a reservation at the same date from another user? Did he try to like add more people than the listing can accommodate, and stuff like that. So basically, we check that the request is valid. Then we want to reserve the listing for the duration of the checkout session. We want to be sure that only one person is able to book a particular meeting at a given particular listing at a given time. And we also want to free that in case, like, as you've seen, I have a few pending session because I wanted to say a few things before this Learn Live session. But if someone just don't go through the payment, what happens? Basically, you set a timeout, and if someone who wanted to reserve or maybe forgot his credit card or finally decide he don't want to pay for that, basically at some point we want to free the pending reservation we made. So we need to have a way to do that. We need also to ensure the validity of the payment, but that's not on our side. That's why we use Stripe for. We also need to update the reservation status once it's paid or if it's canceled or anything. And we want also to have an ability of showing the successful payments in the portal.
Oh, so Johan, just one quick thing. When you say update reservation, so if the payment didn't go through, the reservation is actually freed up, so someone else could pick that up.
Yes, that's the idea.
Okay, that makes sense.
And now I think it's best to show the code of so you can have a better idea of how everything I just said works. So I will give you a quick run through the application. So basically, the three components we will be focusing on is the portal. This one you see, every component is in the packages folder. The portal is there. We have the API and the Stripe service. So I'll start with the easy one, the portal.
Mhm.
So let's have a look uh, first at the rental page. So the rental component is the one you see when you're trying to book a particular listing. And the interesting function that we want to have a look in there is this on rent function, because it's what basically is happening when you start clicking on that reserve now button. And as you've said before, if you have no idea, or basically if it's the first time you're going through this code, something I just do all the time, but you spoiled it for me, is have Copilot explain it for me. Basically, you just type /explain, and yeah, what it will do is basically explain what's going on in there. That's nice, but since we're live and that's a bit too long of a text, I will take over Copilot for this one. Uh, so yeah, what it does is just what we've seen in the schema I just shown before. We call our API and reserve. We want to initiate the checkout session basically by calling this reserve API. We pass in the reservation detail, and what we will get as a result is this particular session URL. So that particular code is just made for local testing in code spaces, so you can ignore it. The important thing is that once you have the session URL, we do just that simple stuff. Basically, but by setting window.location.href, we redirect the user to the particular session URL to move on to the Stripe payment website. So that's it. Once you've made your stuff on Stripe, basically entering your credit card information, at the end, you're redirected to this checkout page. So this page is what you've seen. There's three possibility. Everything went well, and okay, it's a success. You've paid for everything, and that's good. Or if you clicked on the cancel button in Stripe, you're redirected to a different one. So this is the cancel view you will be seeing, and this is one just in case, but doesn't hurt to have like if anything goes wrong that's not expected, we have an error page. But usually that's not something you should see. In case of cancellation, what we do is basically if we detect that a cancellation has occurred, the front end will just call the API and force cancel the reservation. If you clicked, okay, I don't want to pay, we will cancel the booking immediately so that it's free for another customer to book it. And if you go to the profile page, that's basically where you can see all the listings you saved, so your favorites. You can see the reservation you made and also your payment history. So that's basically just a listing of all your user information in there. Now for the more interesting parts, let's move on to the API. And the first API we call is the checkout one. So what happens in there? So first thing, as always, you have to check in the user data. You need to be like extra safe, especially with things like that. So we need to check that we have a user ID, basically to check that the user is logged. We need to check that there's a listing ID. So for the particular listing we're trying to reserve, we need to check that it's existing. So we're not trying like to game the API and try to book a listing that doesn't exist. We have to check for the number of guests, if the listing capacity can accommodate the number of guests we've selected. We need to check that if the time we've picked is in the future, it's not possible to book, obviously, listing in the past. And we need to check if there's no existing reservation that overlaps with the same time range. So once we are done with all the checks, what we do is we make sure to calculate the amount the customer has to pay on the backend, and then create this pending reservation I've been talking about almost for most of the time. So first thing we do, we create this pending reservation with all the details, and we make sure it's persisted in the database. Next, that's where we will initiate the call to our Stripe service. So as you can see, I get this, the service from our configuration and then call the Stripe checkout API. And what we will get from that, I'm just moving on quickly, is basically the
Hey,
session URL.
someone actually had a good question. They were asking how the Fastify container interacts with the Azure function code that you're showing.
Sorry, I didn't hear the question.
Oh, it's in the chat. So someone said, can you explain how the Fastify container interacts with the Azure function code that you're currently showing?
Yeah, I will be moving on to the Fastify part just after that one.
See?
So yeah,
They
this
set you up for it.
this is perfect because it's the next step. Now moving on to the Fastify application, it's the Stripe components.
Okay.
So if you've never seen like a Fastify application, it's pretty straightforward if you've already done Node.js servers in the past, especially using Express. Here we put the models, for example, the payment one. It's just basically the form of our data. You have a plugin folder in Fastify. Everything is a plugin. If you've used Express before, most of what you're doing is middleware. In Fastify, it's plugins. So that means services, middlewares, it's all plugins. We have like, for example, middlewares to help us with the errors. It's set up as a plugin. And we have, for example, a plugin that's the one in particular related to the question, how the Stripe service called the API, that's done through this particular service. We basically do just fetch calls to the API service, to the function app through this particular one. And then, most important one, you have the routes. So this is where you do the routing. You create a route for that. By doing a folder, it will automatically be transformed and added as a base for the routes. So this particular one will be /stripe/webhook. And that's good because that's like the most important one. This is where, in this particular endpoint, we will receive the Stripe events. So we'll receive the body. It's very important that you get the raw body unaltered by anything, because otherwise you won't be able to check that the content, the payload content that you're receiving from the event is not forged. Because you need to also have a Stripe signature, because when the Stripe servers will send an event through this particular webhook, there will be a signature, and you can use that. This is a call from the Stripe SDK to basically you pass in the payload, you pass in the signature, and you pass in your secret. We'll talk a bit about that later. So you can check that this is not a forged event, this is a real one coming from the Stripe server. So you can be sure that this one is not a fake payment, that you don't have any hacker trying to game the API. And then you handle the different events. So there's a lot of different events you can handle for Stripes. So the two most important one is the checkout session completed. So this means you have a payment that succeed, or the session expired. So that means the payment never went through. So that's the two most important, the two minimal use case you need to implement. In case the session was completed, you get the payment data from the event. And basically, that's where I call the function API to create the payments and update the reservation in there. And that's it, we're complete. And if it's expired, we need to update the reservation status and set it to the cancel state. So with that, we've handled the two most important Stripe events. And then how do we initiate this this checkout session at the beginning? First, as I said, we need to check everything. So we have this nice like validate checkout session to check that we don't miss any particular parameter. So that's just the regular stuff. And then this is something interesting. So if you skip that in the video in the beginning, but if you want to run everything locally without caring for Stripe, basically what we did is check that if you did not set up Stripe for your particular configuration, because we did not want you to force like creating a Stripe account and stuff. If you want to have a look at the content source application, we made a quick shortcut. So that's not for the production. So that's why also we print a warning for that. And basically, we directly create the payment. You don't see the checkout screen. So that's if you run the local emulator without anything else set up.
Oh, so that one actually doesn't do the flow, just directly just updates the database. Is what
yes, exactly.
Gotcha.
Now the real stuff happens there. Using the Stripe SDK again, we create the checkout session. We have to pass on a few things like the price data, how we want the tax to be handled, and stuff like that. Where we want to be redirected in case of success. So we want it to be redirected to our portal application, the web app, and also where do you want to be redirected in case of a cancellation. So that's the same route, but we pass in the result as a parameter in the route. So that's the checkout page we've seen in the portal just earlier. And most importantly, you can pass in any metadata you want. So that's where we will set anything we want to have and received with the Stripe events to make sure that we can connect the payments with a particular reservation, user, and listing ID. And I've talked a bit about that. You set an expiration date because for this particular example, we've set it at 31 minutes. So that means that when you click the reserve button, you have 31 minutes to pay unless the booking will be automatically canceled. Mm-hmm. So users are not stuck forever if the listing are not stuck forever if a user decide to not go through the whole flow. And at the end, you get the session URL. And we've seen the most important thing now. Now that's time for you, I think, to work on a bit because I've been showing you stuff and talking a bit. So it's nice to see firsthand how things works and integrates. And I've seen you like a deployed version, but the nice thing with Stripe is that you can totally work locally and test your stuff without having to deploy anything. So if you want to do this very quick and simple exercise, first you have to go to this particular URL. I think it will be shared in the chat and register for an account. You just send an email. It takes less than a minute to register. And once you've put your email, basically what you will see is that screen. You don't need to continue through the different steps. That's all you need to be able to set up a developer account for Stripe. Once you're there, you have to move to the developer tabs in there and move on to the API keys in there. Because we need to have the API keys to be able to communicate with Stripe. So the first key we need is this public key. So just clicking it will copy it for me. And if I want to test everything locally, I need to create a new file in my code space at the root. That's called .stripe.env. I just paste that, and I will show you how you can set up the free environment variable you need to have that locally. So in the docs folder at the root, you can open the one for scenario 5. Initially, it was called the scenario 5. We'll have to rename that later, I think, when more PR to do. Basically, yes, that's the key you have. So everything I'm saying is explained also in this documentation. So I have to take the Stripe public key. I will just copy the other one. We also need the secret key to make it work.
So Johan, just to clarify, these are all environment variables?
Sorry?
These are all environment variables, right?
Like yes, this is environment variables. And I will show you how we can use that when we run the application locally. So next, we need the secret key. So pretend you didn't see that. I just copied the key. I need to put it in there. And then coming back to the slides, so I got my developer keys. I put that in a .stripe.env file. Then we need the Stripe CLI, another CLI that we will use to simulate the Stripe servers and simulate the triggers of Stripe events and send them through our webhooks. So you can go to this particular URL that will also be shared in the chat. So you can install the CLI. You will get basically on this documentation, depending on your system, you pick the option that works best for you. If you're using, like me, Codespaces, you need to just copy the different steps for APT. Basically, you go through the different steps to install the Stripe CLI. I just did that before to not waste time. And the first thing we need once you have the Stripe CLI made is basically move on to these webhook tabs in the developer parts of the Stripe website. You can see here my endpoint for the application that's deployed to Azure earlier. But what I want to do this time is to set up something to test the webhook locally. So I'm moving to that. Okay, you need to log in to the Stripe CLI. I just did that before. And then you have two steps to do. First, you set up a fake Stripe server that will relay the events to our webhook. So I just copied that particular command. And I need to change the URL to add the /stripe in there because that's where my endpoint is located. So then we have a fake Stripe server running locally. Now I need to pick up and copy this particular webhook signing secret to complete my .stripe.env file in there. Okay, we are almost finished in there. Next thing is that I need to pass on this particular environment variables to the Stripe server before I run in locally. So as I said before, it's running in a Docker container. And when we run everything locally, we're running it through Docker Compose. So what I need to do is edit this Docker Compose.yaml file. The Stripe service is the first one, so that's easy. And I need to add this .env file. So you can see the completion of GitHub of Copilot, sorry, in there. It's almost right because I need it to be the file I just created before, the .stripe.env file. So that means that when the service will start, when the Stripe service will start locally, it will take that file and set up Stripe correctly. And that's what I'm going to run now. So I need to open a new terminal. And then I will only start the backend services because I don't need the portal for now. So by doing npm run start services, basically what it does is just call Docker Compose up. So it will run all the containers, including the database. So that's what you're seeing, that all the restoration stuff in there. It will take some time. And basically, let's move back to Stripe because the final thing we want to do is trigger an event. So the particular events, you can see a few different ones. The one I want is not listed there, so I'll just copy the Stripe trigger part, move on, and create yet another one terminal. Okay, Stripe trigger, and the event I want to trigger is the one we've seen in our webhook, is the checkout session completed event. So when I do that, it will create fake data for a few different events and then send it to our fake Stripe server. So that's what you've seen that. Here in the Stripe CLI, you see that it triggered a few different events we don't care about. The one we care about is that particular one, the checkout session completed. And you can see the result in there. That may looks bad, but you'll see that it's good. It's 500. That's what I wanted, so that's good.
I think someone was asking if you could actually see the payment on the Stripe dashboard.
Yes, I will show that just after that.
Okay.
Yes, so here are the logs for our servers. So as you can see, it's all JSON. That's a bit difficult to read, but the one thing I wanted to look at is that particular one when we say, okay, webhook received in there. So that means we went through our webhook. It did some stuff, and at the end, we should be able to see the failure in there. Actually, it went through the webhook 2 times, and the failure should be. Do you see it? I don't see it. Okay, I may be tired a bit now. Okay, it should fail when trying to call our API service because that's why. Basically it failed with an error of 500. It's basically we didn't run the API. And I wanted to show that, to show you how you can debug stuff when running locally. Here, I didn't put a debugger and going through the log is just wasting, but I could have put endpoints in there, breakpoints, and seen what was going wrong and simulating events just using that with the CLI. So that was the whole point. And we were asked if I can show like the events. So this particular one is for the local version. I can show you the events received for the live version. So that's where you can check if everything goes right or wrong. For example, if I kill the application, that's the kind of result you see in there. the event not going through, and it will have retry automatic. So basically, if your endpoint is down at one particular time, it will retry unless you have a successful result at the end. So that's probably the one I did in the demo in there. So I'm a
So
bit.
one observation I had here was that all of these seem so standard that I'm really surprised Copilot can't like help us write much of this. Yeah, at some point we need a thing that says just write the entire flow across files. But it looks very standard, is what I see.
Yes, it's all standard stuff, and it's quite easy to work with, especially as if you look at the Stripe documentation, there's a lot of code examples. I did nothing fancy when implementing the Stripe service. I took most of the stuff directly from the documentation. So.
And also because, I mean, at some point we're talking about composable architectures, right? So what I'm also taking away from this is that because you're running in a container, we could literally have different widgets and different apps talk to your service and use the exact same payment flow, right? So we can actually we don't have to replicate that code on the client side. So this is really nice.
Yeah, basically you can take this example and integrate it in your apps if you want. So that's why also we have samples, right? So let's move on to the final knowledge check. I just kept it with one question because I know it's getting late, at least for me. It's a different for you, I think, in the US. So this is the question. As always, you can go to aka.ms/polls if you want to answer this slide. This is nice. So how is the application notified if you get a successful payment? So A, is it by receiving an event through the event bus? Is it B, by calling an API using the Stripe SDK? Is it C, by receiving an event through a webhook? Or is it D, by checking if a payment was created in the database? So I'll give you some time to answer that. I will also give me some time to drink.
Yeah, and while I was actually watching the chat, I mean, I think a lot of people had good questions on this. Someone had asked, does Stripe provide roles? You know that, Johan? Like, does Stripe provide roles that tells you who's able to see the logs? Are there access controls by role? Like
That's
the
a
owner.
good question. I did not check if there are holes because I mostly use the developer version. I did not want to go to the production stuff, so I didn't want to put real credit cards in there. But yeah, that's something we might be able to check. That's interesting. So we'll give it a few more seconds. I see that people are just following just nice because everyone's got it right as far as I can see.
I'm looking at it going like, I could figure the answer out because you've like talked about it 10 times, and that is the coolest part of that entire flow. So
So yeah, let's move on. The right answer was, again, the C. It was through a webhook. And it was easy. We just went through a whole exercise to just demonstrate how to use that. I hope that was useful. And now let's move on to the last section of this Learn Line session.
yeah.
I'll hand it to you, Nitya.
Okay, thanks, Johan. So Laurent, maybe we could switch to my version of the slides or my screen. Yay. All right. We actually are so close on time. I'm super surprised. So we'll try to keep this short and wrap up. So one of the reasons we wanted to have this section is because this is the third out of 4 parts, and this is the last one where we'll talk development. The next the next episode will wrap up with deployment and testing. So in this, we want to basically kind of give a shout out to some of the other things that are happening that we want to think about, right? So search, you might have remember from the architecture diagram that we have a number of other scenarios coming up. Definitely fork the repo or watch it because there will be more of these implemented and you want to keep an eye on it. But we do have a very basic search experience right now, and it looks something like this. I'm actually, I don't have it deployed in production right now, so I recorded this from before. What you can do is you can go in when you do a browse listing and you search by a keyword. It's actually going to pull up all the things that are relevant to that keyword, and then you can go from there and you can follow the flow through. And what we think is that users will probably want to have this kind of a flow, right? Where it's not that they come in to browse, they're coming in to search for something they want, and then they close that loop. But what's happening is that, so that's basic search and exists right now, and it's using a GraphQL query on the CMS, so we can actually render that. But wait, we are seeing that there's a lot more value these days in natural language based queries, right? So how do we kind of look at cognitive search? How do we look at integrating OpenAI and prompt based queries for whatever we're looking at? There is work already in this area going on for this repo. So you can look at the PRs, and Johan is actually the person working on the OpenAI integration. So definitely check that out. The things you want to keep in mind is when we think about whatever solution we integrate, there is a cost and complexity. Cost for the service, but complexity, users can just use natural language to ask for something, and it's easier than going through different filters. So this is part of the fall for intelligent apps, and we're really focusing on apps, AI, and data. So we talked about where AI can make a difference in things like search. Now I just want to briefly talk about the data aspects of it. So in here, you might have seen as part of this solution architecture that we've kind of talked about different kinds of data. So first, or different storage services and data bases. First, we talked about Azure Blob Storage. If you remember in S1, the CMS has a blob storage because we're using images, we're using files. We might want to, down the line, I don't know, keep audio reviews, who knows. So one of the things with Azure Blob Storage is it's optimized for massive unstructured data. It can help you serve this directly to a browser. You can access it from an HTTPS or HTTP endpoint. And it has client libraries for a whole number of popular programming languages. So it's super easy to integrate. And it's kind of the thing, it's almost the go-to for any kind of unstructured data. The second option that you might have seen mentioned is PostgreSQL. So the Azure database for PostgreSQL in this architecture is being used kind of like backing onto the Strapi CMS. And it actually maintains two kinds of data. It maintains the listings data for the portal, and it maintains the blog articles for the blog app. So effectively, it's the kind of thing where an admin is going to a portal and like actually administering the content in there. But the reason we also wanted to put this in there is to give you a reference sample that shows you how to use a fully managed relational SQL database. Azure database for PostgreSQL has high availability, predictable performance, elastic scaling, and we're using the flexible server instance.
I just want to add something because I just saw the news today, but it seems that we now have like a free tier, free option for PostgreSQL. So that's something we really want to integrate now in the sample.
Oh, we got to add that in here. That would be super cool. I think that is something we all love. All right, we're going to wrap really quickly, but the last but not least, our all-time favorite thing, of course, for most of us is Azure Cosmos DB for MongoDB. I think Johan already mentioned this briefly when we're talking about where user activity data is stored. So payments, reservations, favorites are all stored in this. It's a fully managed NoSQL relational database, fast response time, instant scalability. What we really like about it is that it uses the MongoDB wire protocol. So anything you use that is a MongoDB compliant tool or SDK or API is going to work out of the box with this. And what I was excited by is when I was looking at the documentation is they are already beginning to think about how you could integrate AI-based apps with a Cosmos DB. So like using RAG and vector search, for instance. So definitely check that out. And then I think we're about to wrap. We've just got a few minutes left. So Johan, do you want to do the honors and talk about like, did we actually hit our goals in terms of what we put for the learning objectives?
Sure. So just to have a quick recap of what we've seen during this session. So first, we've seen all about authentication. So Nitya, you've walked us through all the stuff to control the access of the particular APIs and how you can handle the user information using static web apps, manage authentication. Then we've seen the whole reservation flow, what happens when you start booking in the application, and how the different services communicate, and basically how we integrated Stripe to handle all the payment parts. And then we've had the glimpse of what's coming next to the sample, especially this will probably happen in the coming weeks or month. And we've seen also a few different things we may not have been deep with, like the few different storage options that are used inside the samples. And basically, for the next scenarios, it's all about search and AI. And I think you should have a look in the coming months and weeks of what's going on with this particular sample, because it's going to have new great things. I don't want to spoil it, but
that's true. And it's part of the whole reason for us doing this is that a reference sample is something that you can look at for best practices and patterns and learn from. So to kind of close the loop on what Johan was saying, at this time, we've covered the checked versions of the scenarios. We've done 1, 2, 3, and 4. 5 is in the works that he talked about. There's also an events scenario for kind of loosely coupled or decoupled event-based interactions, and then performance with Azure Redis caching, and a lot more. I can't not talk about the last episode of this series. Please do register and show up, because you're going to see me and Savannah Ostrowski, and we both love the products we're going to talk about. So in the last episode, we are going to move from the development phase to the deployment phase. At this point, we're saying, okay, you now know how to build this thing, you know how to use and develop it in code spaces, but it's time to deploy to Azure. How can we improve your developer experience? Savannah will join us to talk about the Azure Developer CLI and specifically about infrastructure as code and how you can actually make everything seamless from provisioning to deployment through a simple single tool and config file. Then I'm going to talk to you about Playwright, one of my favorite tools. It's an open source framework for test automation that will allow you to do end-to-end reliable testing of web apps. So we're going to talk to you about how you can use this with VS Code, how you can use this in code spaces, and how you can go about writing specifications to help you test various features in such complex apps. And last but not least, we could not do this justice without giving a shout out to Fall for Intelligent Apps. So if you've been paying attention, you might have actually seen links to the Fall for IA campaign on various sites. It's actually more than Learn Life. So definitely go check it out. The 30 Days of IA is really walking you through various things, including how to build a Copilot chatbot, I think, and looking through all the different resources for building intelligent apps. Ask the Expert is where you get to talk to the product teams for Azure Container Apps, Function Apps, App Service, and Kubernetes, Azure Kubernetes Service. Hack Together shows you deep dives from the audience advocacy team where they kind of work through some of the back-end services that we're using in Contoso. Cloud Skills Challenge is open. There are 3 different cloud skills that will help you skill up on AI, data, and apps. And last but not least, my favorite, go check out our new community gallery. It's going to have all the videos from all of these series, as well as open source samples that will help you jumpstart your development of intelligent apps. And I think with that, we've got a couple of minutes left. So we should, if there are any questions, if there's anything we can answer. But before we do that, I just want to give a huge shout out to Dina Berry and Glaucia Limers, because I'm seeing the chat rocking right here. So thank you so much for moderating. And Johan, any thoughts before we wrap the session? And also, we'll take any questions if there are any.
Yeah, I just want to say that I'm hungry.
And I also want to say that I'm seeing many folks come back I think it's 5 sharp, I don't know. And your comment on the 404, I actually figured out why that was, but we'll save it for the blog post. So do kind of follow and check up. But other than that, yes, Johan and Laurent are actually in a much further time zone, so we should wrap up. Thank you all for coming for Learn Live. Don't forget to check out the next session. And we all hope that you will give us feedback, star the repo for Contoso, and give us your PRs. Anything else, Johan?
Thank you, everyone, for following along. And it has been a fun session. And see you in the comments, see you in the GitHub repo.